Now, why is that red and not, for instance, authorization to launch like we had last night?
Well, good question. I don't have the precise answer to that. Is, again, it's a kind of a safety concern after all, and safety concern, leads to not authorized launch.
No, but it seems to me that there's a hierarchy of on the status panels, and there's two apparently: base, launch base, and the authorization to launch, which seem to be umbrella covering more than one element. If you have a red on the weather, for instance, you get red weather plus you have a no-go on the authorization to launch. Does that exist? That sort of hierarchy?
Well, all I can interpret maybe is depending on the violation of the requirements, then this is treated differently. I think there is a hope that this value will come down, and it's not as. I don't think it's going to be as critical as the last night limits or last night situation.
Was there anything else that you wanted to mention about last night? Or did we cover the problem completely?
I believe so. One thing we can say is the safety of the property and the people is very important. We have to really have to be very careful on it, and I think we are.
Sure. Priority.
Sure, that's the priority, and after satisfying that, then we look for to succeed our missions.
Now, coming in from the right on the launcher are these wires and plumbing and things. I assume that's the electrical connections and fluids and things you were talking about that the computers are checking. Is that right?
That is correct. And
so one is going, the bottom one is going to the boosters there? Or first stage?
No, first stage. The most important connection, of course, is the umbilical, like fuel umbilical lines, like hydrogen and oxygen.
For the third stage? For
the third stage. The tapping of the fueling is continuous. Like, for example, we have a pause now, and we have to keep doing this. We want to fly with the topped fuel tanks of the third stage. It is very important for us.
Now, why is this topping up necessary?
Because due to the conditions and the thermal conditions, and also due to the temperature of this cryogenic fluids.
Which is very cold.
Very, very cold, and we lose some of this fuel. We see the evaporation of this, although they are at the very, very minimized levels, but still, and we keep fueling for the portion which is lost during this process.
So this is why also you have to fill these tanks at the last minute. You couldn't fill them 2 days ago like
Sure.
you do the first and the second stage.
Sure.
Correct?
Definitely, and also this fueling should take place after the gantry is removed. We're going to see these arms being connected to the launcher up to the 5 seconds before the liftoff, and we'll see them hopefully tonight.
Open.
The opening of these arms. We'll get to there, hoping.
Yeah, when we come to that split screen image, we'll give a good explanation of that, because that's something that everybody should know. That's the last thing that you'll see is the opening of the arms.
Correct.
All right, we're still waiting for a green on safety to switch, red on safety, sorry, to switch over to green. How long have we been holding now?
Well, we are almost like a little more than 6 minutes into the launch window. So we consumed almost up to 7 minutes of the 55 minutes wide launch window.
So we're still okay.
Yes, we have lots of time to perform the launch.
Actually, talking about countdown, this is what we call the final countdown when we come on the air. But actually, the real final countdown starts, 36 hours or 39 hours? There's a lot of stuff that we don't see.
Yes, because today's the launch date, but 1 day before, first and second stage fueling takes place.
What, 1 day before launch day?
1 day before launch day. In this case, today we are delayed 1 day, and this took place on Wednesday. Launch date minus 1 day, that was originally on Wednesday. And Wednesday we fueled the first and second stage fuel tanks.
You mentioned that we filled the first and second stage, the storable propellant, the day before launch. Now, supposing when we're delayed, how long can they stay filled? Because you mentioned you had to drain the third stage. Is there a point where you have to drain the other stages as well?
There are some other criteria which may dictate the first and second stage defueling to take place. But not more than a few attempts, and after it is defueled.
So you have to wait a couple of days for the storable propellant before you'd have to drain it.
Correct. Correct. But again, it may be dictated by some other concerns, like,
For instance?
For example, number of attempts, number of launch attempts for the third stage, and third stage hardware. It may dictate later day launches, and then as a consequence of that, the first and second stage defueling may take place. There are some very strict criteria.
You started to talk about the other events in the countdown, because the countdown goes back a couple of days even before the filling of the storable propellant stages. Is for instance, a launch campaign, is that that's part of the final countdown, isn't it?
I think it depends where you draw the line. Yes, launch campaign itself, it's a maybe countdown. For example, one important mark is the 5 working days before the launch day. It is where the payload composite, which the satellite and the fairing assembly, it is transferred from where the hazardous operations takes place, from that building to on top of the launcher. For example, that's a very important milestone.
So you could say that once the launcher is all together with the payload, the final countdown starts? Is that what you're saying?
In our opinion, the final countdown is like 2 days before the launch, which we called launch readiness review. All the campaign is summarized, presented to the authorities, all the anomalies, all the signatures of the launcher and the test data, and then the authorization is given 2 working days before the launch.
Do you want to explain those 3 clocks there, TD, TU, HO? TU, I know, is a universal time, right? TD is what?
That's the 6 minutes mark.
That's where we are in the countdown,
yes.
I guess. Huh? That's countdown time, okay. So countdown, as far as the sort of showy part that we see here, the last couple of minutes seems, I don't know, some people might think it's a way just sort of to build suspense and tension. But actually, countdown, it begins a long way, a lot earlier, sort of a carefully developed procedure to prepare the launch and to, I guess, to test out all the systems. And as you were talking before about saving some things until the latest moment, so you don't use them up or you don't burn them out or overuse them.
Sure, but as you may appreciate, when you perform some tasks 5 or 6 days before the launch, it has more margins, as we know. We have very tight margins now. We have a launch window, for example, that we can perform the launch. We don't have that luxury of spending and wasting the time. So because of satellite-dictated launch window, the liftoff should take place at a certain given time. And
that's right.
For example, Kourou time and local time, that we have to lift off by 10:11 p.m., which we have
local time.
Yeah, local time, which we have a little more than 40 minutes elapsed time that we can lift off. which is arrived by the satellite needs at the injection point, which satellites define, and they drive the launch window.
They're the ones who create the launch window and a lot of other things that the launcher does not.
Well, our system, we can launch all around the year in 24 hours a day.
In two directions.
Except when this kind of constraints also, it holds us to liftoff.
So problems with the weather last night and tonight. Still waiting at 6 minutes. We're in the middle of the launch window. We've got a safety hold because of winds, because of ground winds.
Yes, because low altitude winds measured at the Kourous beach. The last data that we have received, it was like 10 meters per second instead of up to 7 meters per second allowed limit.
You're looking at Michel Mignot, who's the director of the CSG here. The decision to build a launch base in French Guiana was made in the 60s by the French government. It chose Kourou. There were, I think, 13 or 14 candidates for the new launch site. They had an old launch site in the Sahara Desert. And the decision was made by the French government to build a new launch base for Europe. France became the world's third space power. And Kourou was chosen precisely because of the ability to launch east over the ocean, away from populated areas. Also, we're on the equator, which is a big plus. Maybe you can explain that, because the rotation of the Earth, without being too technical, the rotation of the Earth gives us a more direct line to space the closer we are to the equator, correct? Saving fuel for satellites, which means a longer life. Basically the story.
Well, our injection spec, for example, calls 7 degree for the inclination, which...
You know, I've never understood that. Can you explain that?
It is very difficult to explain through a mic. You know, you need a drawing board to explain it. But just talking with the figures, the less magnitude the inclination equates, the less fuel that satellite would consume in order to get to the geosynchronous orbit, which is at the equatorial plane.
Its final orbit.
Yeah.
So in other words, the farther north from the equator, or for that matter, the farther south from the equator that you launch,
you consume, after the satellite is separated from the launcher, it consumes more energy, more fuel
to get where it's going. Now, how about for the launcher itself taking off from the equator? Does it get up into space quicker?
Of course.
Then this is the idea of the rotation of the Earth?
Yep.
So, yeah. Could you explain that a little bit to them? No. So the launch window, you mentioned, this is dictated by the satellites, and this is why we're launching at the time that we're launching. I mean, we can't just launch at any time. We can't launch at noon. If they have a certain window that they have to respect, they have a certain inclination, an angle that they're going to.
Well, there are certain important parameters come into play, like satellite thermal subsystem, satellite power subsystem needs, and their battery management, the tasks that they perform. Basically, the satellite sun geometry at the injection, it determines the launch window. And like we said before, launch windows are strictly dictated by the satellites that we inject into transfer orbit.
Because most of the launches take place at night around this time.
Also, there are some like midday launches or early in the morning launches. Again, it depends on the season. It depends on the satellite power subsystem and thermal subsystem needs.
We're still holding, folks, at 6 minutes, right at the threshold of the synchronized sequence, minus 6 minutes, for countdown to tonight's launch of Arianespace flight number 94 with the first of the new Intelsat 8s. Yves Guérin, the mission director. Behind him, Pierre Bardière, one of the DDOs, the dean of the DDOs, I think.
Maybe we can say a few words about the Ariane 4 family launchers. This launcher has 6 different configurations, depending on the number of the boosters and the type of the boosters. Tonight we are using the 44P version, which is the 4 solid boosters.
And that gives us, that's good for how many tons? 3.6, 3.5? It's not the most powerful version.
No, the most powerful version is the 44L version, which is with the 4 liquid boosters. Again, it's a single launch. The satellite volume and the satellite mass dictates what would be the launcher configuration. And this is the, I believe, 7th 44P that will be launching.
I think they use the largest version, which is the 44L, is the largest, the heaviest Ariane, is it?
Yes.
44L? I think
almost like that weighs
you can get
480 tons, and it has a liftoff capability. Like the last launch, V093, we performed a launch with 4.9 tons
double launch
payload to liftoff capability. It was a double launch.
And I think for the Intelsat 6s, which were bigger than these, I think it was the 6s that were 4 tons. You must have used that launch vehicle. Yeah.
Well, if you look back to the Ariane evolution, Ariane family launchers evolution, always the launch systems developed and evolved to satisfy the customer needs. Also, when we look at the satellites evolution, the satellites got larger, heavier, more channels. So their need, forced us to improve the performance. And
the market's changing constantly.
Yes.
And Ariane, of course, adapting to better meet customer needs. However, the Intelsat 8s are lighter than the previous generation, isn't that right? They got a lot more gear on them and more channels and more capabilities, but...
Well, also the satellite manufacturing industry and techniques and features are changed, depending on their mission and needs.
Terry Edwards, now, he's on the phone with probably Washington and the S1 people where his satellite people are, I imagine, huh?
Yes, he's the mission director of the Intelsat, and he's playing a very key role coordinating his spacecraft, getting prepared with a launcher simultaneously, targeting to the same liftoff instant. He coordinates his activities with his people in S1 building, which is some 13, 14 kilometers away from the launch pad where the satellite is placed on top of the rocket.
It's not far from mission control here. It's just
around the corner.
It's just around the corner.
Yes. We have a little more than half an hour that we can lift off.
Half an hour of the window left. Waiting.
Yes, waiting, and
Waiting's part of the space business, isn't it? It's like the
well,
movie
we can
business.
control the things and events up to a point, and then we cannot control the weather.
Although the weather normally here, it rains a lot. I mean, they have a main rainy season, and then that's not enough. They have sort of an auxiliary rainy season, second rainy season. But it's part of the reason for Kourou being chosen was also because there's no hurricanes and there's no earthquakes and there's none of that.
From those concerned standpoint, it's quite a stable place, and look, I personally don't recall any launch being aborted because of the weather conditions. I remember that we did not lift off at the opening of the launch window, but we launched at the end. So it was reported by the authorities last night. It was the first time that high altitude wind caused a launch abort. It was the first time.
And the 12 to 15 to 20 kilometers where those high altitude winds were, that corresponded to, I have here, 80 to 120 seconds of Ariane's flight.
Yes.
So that's still the boosters in the first stage. It's just the end of the boosters, actually, right?
Well, the sold boosters injection happens at the 1 minute 10 seconds. It's exactly at the 70th second mark into the flight. We eject the solid strap-on boosters. That equates almost like at the 12 kilometers altitude.
Now, you see Chef de Mission, that's Yves Guérin in the striped shirt. Now, what does he do exactly? He's up in the front row?
Well, the mission director has various roles during the campaign. He coordinates all the spacecraft coordination activities with the customer and with the launcher. So the launch campaign for the satellite, it is run smoothly for the target launch date.
That's part of a mission manager's job too, isn't it? Isn't that what you do?
Well, mission director takes, because mission manager, we don't spend the entire campaign time here. Mission director, he does, and he takes that role, and he assumes the mission manager's roles when we are not here during the campaign.
As an interface between the launch base and the customer?
Yes. So for a typical either single or dual launch, let's take a dual launch option. There are two customers and a launcher. The early phase of the campaign, these three parties run their activities in parallel.
Early phase of the campaign, meaning when?
Meaning like after the spacecrafts arrived to French Guiana, they're subjected to some performance verification tests to make sure.
How long before launch they arrive in French Guiana? A couple of weeks, right?
Depending on their launch campaign approach and the tasks that they perform, that depends some either 6 weeks before or 4 weeks before, depending on the launch campaign attitude of the customer and their constructor. So the first thing they do is subjecting their spacecraft to some performance or functional verifications to make sure that transportation did not degrade the health of of their satellites.
This sort of thing goes on in the S1 building.
S1 or S3. Again, that depends on the philosophy of the launch campaign of that specific customer. Some customers directly go to the S3 building.
But I thought S3 was for what you call the hazardous operations, the filling and things.
Yes. Like I said, some of the customers, they prefer to do very small amount of functional verifications, which they feel comfortable to verify the integrity of the satellite after the transportation. And some customers, they take a little more conservative approach, and they do run some good size tests to compare their data to the some of the data that they collected just before the transportation at the contractor place.
The satellites always come to the base by plane? Do they ever come by any other means? They're shipped?
Very rarely. I think one time by ship. But usually the transportation mean and media is the air transportation.
They have to have special containers or special airplanes? I mean, could a satellite fit into an airplane?
Yeah, there are several type of planes, like jumbo jet, like Boeing 747.
A special one has to be, I imagine.
Of course, without seats. And we have like Antonov.
Antonov's a Russian plane.
Yeah, and then we have Belfast.
What's that?
One of the cargo plane.
We're waiting. You see the red at 6 minutes up in the right-hand corner of your screen. We have a red on safety because of ground winds on the beach here in Kourou that are depassing the safety parameters. The weather, of course, is giving us problems. It is an all-important factor in any launch, that's true. Sounding balloons are not the only means that are used to test the meteorological conditions. There's also radar and satellite image and lightning risk measurements. Lightning, I think, causing a greater risk than rain to the launch vehicle. Ariane, however, cannot launch in just any weather. As we are seeing, of course, certain conditions have to be met for liftoff. Wind speed has to be lower, as Mesut was saying, lower than 14 meters per second, according to the wind direction. The horizontal visibility has to be better than 600 meters, and the cloud ceiling has to be higher than 250 meters. Dave Griffiths in the foreground, and Terry Edwards behind him. The Intelsat men, numbers 1 and 2. Some discussion going over there at the Intelsat camp with Yves Guérin, the mission director. Maybe we'll have some news for you shortly. Mesut was telling about how the satellites come here by air, but the Ariane launch vehicle comes by sea. It's built in Europe, of course, and shipping her stage is a complex matter to get her here. The components are too big for any normal-sized plane, not like the satellites. They have to build special containers that travel down the Seine to Le Havre in northern France, and they cross the Atlantic by cargo. They arrive at a port here, then they're taken by road to the CSG assembly buildings, and the 6-week launch campaign starts. Well, that conference is over. I wonder what that was all about. Maybe we'll get some information from them. Have some more news for you. We're still stuck at 6 minutes. The launch window's ticking away. We're still good for launch, though, and waiting for the green to show up on the safety, waiting for the wind to die down. Wind giving us problems the last 2 days here at the Kourou base. Some more notes on Final Countdown. I think it's interesting to look at. We were mentioning how Final Countdown is much more than what we see on the screen on the video show. It actually lasts 34 hours, as Mesut was saying, beginning on the day before launch. And this has actually 4 phases, from H-34 hours to H-11 hours. H meaning T, I guess we say in English, and T0, to T-11 hours and 50 minutes. This is when the launcher is filled with the storable propellant. It's not solid propellant, but it's the hydrazine mixture and nitrogen tetroxide. That's in the first and the second stages. And if we're using liquid boosters, the liquid boosters are filled at that time, 1 day before launch. But I guess the busiest day is launch day, not only because of launch, but there's a lot of these final activities from minus 11 hours 50 minutes to minus 4 hours and 5 minutes. All this has been going on today. The umbilical tower and the gantry are being prepared, and the launcher and the launch table on which it sits, clamped down by those heavy hooks, are armed. And in the case of solid boosters, like we're using tonight, final preparation and arming of the solid boosters takes place. All that takes place today. But that's not all. From minus 4 hours to minus 6 minutes, which happens to be where we are sitting at the moment, the third stage, the cryogenic stage, is filled with the liquid hydrogen and liquid oxygen, and this usually starts at minus 3 hours and 35 minutes, as it has today. So a lot going on leading up to this final countdown. Mesut has come back from trying to find some information to pass on to you. What did they tell you down there?
Well, the wind condition, it keeps the same behavior as before, which caused this pause in the countdown.
No change.
No change yet. We're waiting.
Now, what's been your experience during holds of this kind? Is it more or less the same procedure? People wait for the appropriate site to radio in or to send in their message that everything is all right?
Of course, and I've experienced through some chronology countdown stops, but we picked up and we've launched. I hope it will be the same thing.
So the Ariane space people and all the CSG officials are working hard to coordinate their activities, making sure we can go.
Of course, of course.
Now, what does the COL do during a countdown?
Well, he's the man leads the launcher integration and preparations, and then he is leading the launch center operations during the launcher being brought to the flight and liftoff configurations.
This is the wind direction which is coming off the beach there, you think?
Well, I don't know what this
desk
chart.
is that on?
This is one working paper of.
Can't tell.
I don't know if it corresponds to the problem that we're experiencing.
You were saying what a COL does during a hold.
Well, simply, they hold the campaign at the 6-minute mark, and he's anxiously waiting.
He can't do anything about it.
No. The authorization to be given, and then he will authorize the restart of the countdown at
The COL authorizes the restart of the countdown?
in the launch center. I mean, of course, he receives the information from the cognizant authorities authorizing that weather concern is gone and we can continue with the countdown. Then he leads the operations in the launch center.
Would you say that during negative time, some of the most important things are going on up there at the launch site, the launch base?
Sure.
Yeah. Led by the COL and his team.
Coel and his team in the launch center building.
And then once the launcher lifts off, the COL's work is done?
Yes.
He does nothing, he sits back and watches?
Yes.
Or he can go home?
He cannot leave. He cannot leave the site because of the some safety concerns, and they have to spend some time before the doors are opened and people start leaving.
But what happens, I'm told, after every launch, and it has happened non-stop since the very first Ariane flight of 1979, is that the pad is prepared for the next launch right away.
Yeah, it takes. Let me answer the phone just a moment.
Since 1979, we were saying it's a non-stop process here. The pad is made ready for the next launch, and all the telemetry and all the data from the previous launch are analyzed, which, well, you can imagine the massive stocking of archives that they have now after close to 100 launches at Ariane, and analyzing each new bit of data from each new launch makes for much more precise calculations and a much better knowledge of the launch vehicle and its systems. You were saying.
Yes, I think this will be the input that everybody is waiting for. I was informed by the authorities that in a very short time the automatic sequence will be authorized and we'll resume the countdown.
Well, that's good news. How are we doing on our window?
Well, window, we still have almost like 5-6 minutes to start the automatic sequence because with the original window that the liftoff can take as late as 10-11 p.m. And the 6 minutes of it we need
11 minutes after 10?
yes,
Is that what you're saying?
that liftoff should take place, and we need 6 minutes to get to that point. So if we start within a few minutes, no problem. We can still satisfy the original window.
It's 11 minutes after 10 Kourou time. That's 10 minutes from now. If you're keeping score around the world, Washington and Tokyo. So we're waiting for that milestone. It'll be very welcome for everybody here. This red on safety, which has kept us stuck here at 6 minutes before we even started the synchronized sequence. We weren't even into it yet. So we'll start that all over, and the computers will check everything down to H0, and hopefully we'll be on our way.
But also in the past, we've seen several times that in certain circumstances, with the agreement of the customer and its satellite spacecraft contractor, I've observed that launch window being extended. Okay,
there we are.
Automatic
Début de la
sequence
séquence
started.
synchronisée.
All right, the DDO has just called out. We're finally past the 6 minute mark. We're into the synchronized sequence, which you know all about because we explained it twice already. But there are some details, I think, which we should go over. This is the synchronized sequence. These two computers checking everything out. If they find some anomaly, which nobody hopes that they do, we'll go back, of course, to 6 minutes again. But I think we've had enough of 6 minutes, so we're going to go all the way down to H0, right?
Yes. I think we deserve that now.
Well, a little suspense, right?
That's true.
All right, we should be coming up on the shots of the gantry withdrawal, I think. In just a minute, or are we going to the CDL?
Well, we'll see about it. Yes,
CDL.
there's the CDL, which we say launch center.
Now these men, this is the COEL, who's a launch base manager, and his crews. They are about 1 kilometer from the pad, about 14 kilometers to the northwest of where we are here in Mission Control. And they're closer to the pad, so of course they have to be better protected. They're in a bunker, surrounded by walls that are about 1 meter thick. And their work, of course, is very important. Just one of we can't have cameras everywhere across this large launch base, but that is one place where essential things are being done tonight and where data is being relayed into Mission Control, into the DDO, the man you saw, who calls out the messages that he's been getting from people like the COEL and from the telemetry people who we'll see a little later, and from the weather people who we heard a lot of already. Now, the gantry, these are shots that were taken just this afternoon. The gantry withdrawal, which is one of the major visible events, one of the last major visible events, huh?
Very heavy-sized mechanical activity.
Now, why do they save this until 5 hours, what is it, 5 hours before launch?
Yeah, because our countdown allows us to keep the gantry up to that moment, which is like a little more than 5 hours before the liftoff. We would like to protect our launcher from the heat, from the external conditions, as much as possible.
How far is it withdrawn from the launch vehicle?
It is pushed 80 meters away from the launch tower.
80?
80, yes, 80.
Now, with liftoff just more than 3 minutes away, we're getting reports of some of the final operations. At 3 minutes and 30 seconds, we had satellites go into launch configuration. Now, what's that mean?
Meaning that the satellite is switched to its own internal power on batteries. Like its batteries are providing the energy needed by certain spacecraft components. Which same thing is going to happen at 1 minute before liftoff for the launcher.
So the satellite has to have power to send telemetry back to the ground stations.
And also to receive the signal. Yes.
I see. Now this coming up is a very important shot, which we want to get a good explanation of the split screen image of the cryotechnic arms, the feeder arms feeding the hydrogen and oxygen into the third stage. And this shot here, this split image, is the last thing you're going to see before we have liftoff. Now,
correct.
Let's explain that a little bit. We have the computers that you so diligently explained, checking down the 1,001 operations down to launch. You can explain the liftoff sequence, which includes these cryogenic arms. The computers check everything, and when everything is down at H0, the computer gives the order to fire the main engines, right?
Yes, the first stage main engines ignited, but the liftoff doesn't take place right away. The system waits until enough thrust is built by those 4 main engines. When that instant comes, the solid boosters are ignited. At the same instant, the hooks are released.
So some more shots of the COEL checking out their final systems up at the launch base. So what happens is we're at T0, and we have the computer saying, all right, fire up the main engines. That's 4 main engines.
À tous de DDO, attention pour au moins 1 minute.
That's the DDO going to call out the 1 minute mark.
Almost.
Top, moins 1 minute.
All right, we're down to the final 60 seconds. Yes.
Almost up to 4 seconds it's passed until enough thrust is built by those 4 engines.
And the computers check out the pressure.
Yes.
Yeah. The same computers we're talking about that have done all the other work.
Onboard computers. This time onboard computer and then
different computers.
Yeah. Onboard computer, and then the hooks are released, and then the solid boosters are ignited, and then the liftoff takes place.
Okay, so solid boosters last of all. All right, so watch out for the cryogenic arms. The arms will swing open. We can't have launch without open arms. We'll cut away, let you watch the last 10 seconds. You'll hear the DDO say it, and we'll be back.
À tous de DDO, attention pour le décompte final.
After Ariane clears the tower.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage N220. Allumage des papes. Pression correcte. Tous les paramètres sont normaux, début de manœuvre en roue libre. Tous les paramètres sont normaux. Extinction des papes.
Okay, the DDO has just called out the burnout of the boosters, and they'll be jettisoned shortly. You saw Ariane rise beautifully in the sky. You saw the 8
Tous les
motors.
paramètres sont normaux.
All parameters are normal, says the DDO. When she rolls over, there are 2 rollover maneuvers, and they're to assure better ground control with the radar control for the ground, right?
Correct.
Okay, the curve here. Can you explain what we're seeing on the right now?
Well, the T indicates how many seconds after, how many seconds passed.
Largage des papes.
Jettison of the boosters, says the DDO. Yes, moyenne.
Altitude is like
Tous les
14
paramètres sont normaux.
kilometers. The launch reached to 15 kilometers altitude, and the speed of the launcher is 0.3 kilometer per second right now.
Okay. Solid boosters burn for about a
Tous les
minute.
paramètres sont nominaux.
A little more than a minute. A minute, and then the jettison takes place.
By a system of springs, I think. Right?
4 ejectors push each solid booster.
Okay, you can see on the left of the screen the cursor climbing up the trajectory path. It's the nominal trajectory
Tous les
transposed,
paramètres sont toujours normaux.
It is, yes,
transposed over the actual.
correct.
Now it's climbing, as you can see, toward up on the right, SEP 1-2. That's, of course, separation of the first and second stage, and you'll hear the DDO calling those out. First stage is burning now. It'll burn for about 3.5 minutes total, dropped out over the Atlantic. We mentioned the CSG chosen for its ability to fly over uninhabited areas. Now this is the launcher being tracked by our infrared heat-seeking camera, is that right?
Correct.
Propulsion et trajectoire nominaux.
Propulsion and trajectory are normal, says the DDO. So we're doing fine. Speed 1.3 kilometers per second. 47, approaching 50 kilometers up.
Début de deuxième manœuvre en roulis.
Now, he says the DDO just said the second rollover maneuver. How come there's so much time between the two?
That is determined by the trajectory of the launcher.
Which is built into the computer program.
Correct. This is the predetermined attitude law controls the launcher attitude.
So the launcher's flying just by the program now.
Tous les paramètres
Correct.
sont toujours normaux.
And then the guidance unit takes it over after the second stage is ignited.
Extinction premier étage.
There's the first stage burnout, and we'll have second stage ignition shortly.
Séparation, allumage du second
There's
étage, pression normale.
So there's the stage separation, first and second, and normal pressure in the second stage, which has just been ignited. Now for stage, it's a little
Tous les
shot.
paramètres sont normaux.
It's an idea of what's going on up there. The cursor climbing up to SEP Quaff. Quaff is the fairing. That's the next separation. We always like to give you this the Ariane mass profile as she sheds weight, tons of weight, as she begins to fly. Total mass of the launcher tonight at liftoff was 357 tons. And mass after the first stage separation, which we just had, down to how many? 56.
Tous les paramètres sont normaux après
Correct.
250 secondes de vol.
Now, stage separation is detected by the onboard computer in the vehicle equipment bay, is that right?
Correct.
How does that happen?
Well, separation sequence is activated when the onboard computer detects the half thrust, which
Largage
corresponds.
de la coiffe.
There's the fairing separation.
Tous les paramètres sont normaux.
Everything is normal. Second stage is burning one Viking engine. Ariane 4 is now moving at over 5 kilometers a second, as you all know. A speeding bullet travels at 800 meters per second. So Ariane, after 3 minutes of flight, is traveling at much more, traveling at 2,800 meters per second.
Yeah, when the onboard computer detects the half thrust of the first stage corresponding to depletion of one of the fuels.
So it detects that there's a drop in fuel, there's less thrust. Yeah?
Sure.
Yeah.
Sure, and then it activates the separation system, and this connection is obtained by the pyrotechnic cutting cord.
So it's a different separation system than we saw for the
Tous les paramètres
boosters.
sont normaux.
This is a shot of the this is the telemetry center at the Montagne.
Extinction du L33.
There's the extinction of the second stage. It was a shot of the telemetry people who you can see their telemetry.
Allumage H10.
There's the third stage ignition. So we're into the long third stage burn now.
Pression foyer normale.
Everything is normal. Just a word about the fairing. They have to have a fairing because
Début activation SCAR.
satellites are
Tous les paramètres sont normaux.
made to work up in space away from the Earth atmosphere. So they have to be protected from which can be harmful Earth elements.
As long as we pass that point and when the conditions are okay, that spacecraft can withstand all those conditions, then the fairing is jettisoned. Because by doing that, we get rid of the unnecessary weight to be carried, which impacts the performance of the launcher.
And speaking of weight, remember our mass profile, we lifted off with 357 tons. After first stage separation, 56 tons. After
Acquisition par la station de Natal.
second stage separation, we're down to 17 tons. And we've just been picked up, the DDO says, by
Tous les paramètres sont normaux.
the first downrange station across the border at Natal in Brazil. From Kourou, the launch vehicle from liftoff is followed by 3 radar telemetry stations. Here, there's one at the weather spot here that's a shot of it right there. And the Montagne des Pères, which you saw, which is the main telemetry center behind Kourou,
Tous les paramètres sont normaux.
20 kilometers east of the pad. And there's one also at Cayenne on another hill called Montabo, 60 kilometers from us. And one by one, they lose the signal, which is quite normal, and the signal's picked up by the downrange station.
We have a quite reasonable overlapping coverage area, so one doesn't lose before the next one picks the signal.
Propulsion nominale, trajectoire normale.
Everything fine on board, says the DDO. We're doing very well. We're in the third stage burn. And I think since we're in the third stage burn, it's time for Ariane Space quiz number 94. What do you say? Right?
I already gave the answer.
Well, maybe nobody was listening. It's Ariane Space quiz number 94. Tonight's question, how many 44Ps have we used before tonight? How many Ariane launchers in the configuration of 44P have we launched prior to tonight's flight number 94? We'll give you the answer in a minute. But before we do, tonight is only the second launch of the new year, and I think it's still early enough to take a quick look back on 1996. It was a big year for Ariane. We opened an office in Singapore in December, you know that. As far as the market goes, Ariane continued at 60% market share with 19 new contracts signed, representing over, I think, 60 tons of hardware to launch into space. We launched 15 satellites with 10 launches, 1 flight a month, except for October and December. Also a big year, worthy of note, for the production people, for the partners. Flight equipment delivered in 1996 beat all records.
Environ 600 secondes de poussée.
The first and third stage, built by Aerospatiale, they delivered record numbers. The Fiat people, BFD, record number of solid boosters. Ditto for the DASA folks with their liquid boosters in second stage. And the SEP,
Tous les paramètres sont normaux.
builders of the Viking engine, delivered 77 engines in 96, which is a big record. All record quantities of equipment delivered in 1 year, 1996. We're doing fine on board. We are at 5 kilometers per second. That's about half of the speed that we need for satellite injection. By the end of the third stage burn, we'll be up to 10 kilometers per second. As Ariane crosses the Atlantic in about a quarter of an hour.
Tous les paramètres sont normaux.
Everything is normal. We have, about another 8 minutes of the third stage burn? We're 256 kilometers up.
And the speed is almost 6 kilometers per second.
So we're picking up. The answer to the quiz, by the way, how many Ariane 44Ps have we launched before tonight? Mesut, tell them.
This is the 7th 44P configuration launch.
Okay, it's not one that we use a lot.
Fin de la visibilité Kourou.
All right, now, we've just lost, quite normally, the signal for the Kourou tracking stations. We're being tracked now by Brazil. The Ariane 44Ps, just some details of those missions. The last one goes back to Flight 87 last June, which was an Intelsat, which was the last of the 709. Flight 83 was an N-Star in 96. Flight 80 was the ISO, the Infrared Space Observatory for ESA. That was in 95. Then the other N-Star, the N-Star A, was in Flight 77 in August of 95. And then we have to go back to Flight 46 and 43 in 1991, which were 2 ANIC satellites for the Canadians. All those 6 were the Ariane 44P missions. And tonight makes the 7th one.
Yeah, this is a rare configuration because Ariane 4 launch system is designed and optimized for dual launch.
Tous les paramètres du vol sont normaux.
And when we have single launch like this, we need to use whatever the satellite payload weight dictates. Whatever the configuration is dictated, then we use that configuration, and that is not too often used.
Trajectoire nominale, tous les paramètres sont normaux.
Trajectory normal, propulsion normal, everything normal aboard the third stage. You see on the cursor H10. H10 is another way of saying the third stage. I think we're using and X, of course, means extinction, burnout. The H10, I think we're using what we call the stretched third stage, which we've been using for the last, 20 launches?
Correct.
Yeah, it gives us a little more...
Il reste environ 400 secondes de propulsion.
Another 400 seconds left, says the DDO, of thrust in the third stage.
Well, the third stage has evolved from the first, Ariane 4 launches, Ariane systems launches, I should say, and the idea, the objective is, of course, to enhance the payload liftoff capability.
Notice on the curve here that we go up, then
Tous les
go
paramètres sont
down
normaux.
and go up again. Is there any reason for that?
Yeah,
Are we slowing down?
No. How do you say in English? I lose that word now. Just the exact opposite. We lose
Acquisition par la station
altitude,
d'ascension.
but we gain some speed.
I see. Okay. We're picked up by the Ascension Island Station. That's an ESA station out in the middle of the Atlantic on the British island there, which was built in '91 when
Tous les paramètres sont normaux.
NASA was going to close its support station there. So we have Natal, Ascension Island, and then the final station is across the Atlantic in Gabon at Libreville, which will pick up the launcher soon. February, there's some... Yes?
There's also, we can see
Tous les paramètres sont
we
nominaux.
lose some altitude, but then the speed is increasing. The
Speed is increasing, right? We're up to 7 kilometers per second now. Fine. Started to say February have some milestones for the Ariane program. On February 26th, it's exactly a year ago, 5 years ago, first launch in '92 of a Superbird and an Arabsat. And Ariane accomplished her very first launch north in 1986, 11 years ago, in February the 22nd, with Spot 1.
Il reste moins de 300 secondes de propulsion.
Less than 300 seconds of gas.
for the power flight of the
in the third
launcher.
stage. Time to talk about the satellite a bit?
Well, I think you have all the good data to tell.
I sure do. First of all, an interesting broadcast note for our friends at
Fin
Intelsat.
de poursuite Natal.
We've just lost the Natal station quite normally, so we're being tracked by Ascension Island now. For our friends in Intelsat in Washington, tonight the satellite that is assuming the broadcast link between French Guiana and the U.S. is, you guessed it, an Intelsat 601, launched by, right again, Ariane Flight 47, October 91. So I guess you can say that the broadcast is coming to you people, courtesy of Intelsat, for Intelsat, and about Intelsat. I guess that's what we call a charter. There's Dave Griffiths. Dave Griffiths is number 2 to Terry Edwards. He's a Welshman. He doesn't have a Welsh accent, though. He speaks like a North American. I asked him why. He says, well, it's very simple. I was born in Wales, but I couldn't sing, so they threw me out of the country. Went to live in Canada. All right, Intelsat, the 801s, first of the new series, they're going to bring higher power to the fleet.
Tous les paramètres sont normaux.
38 transponders in C-band, 6 in KU band.
Il reste moins de 200 secondes de propulsion.
44 in all. Steerable KU bands. It's a feature of the 801s to accommodate the mix of Earth stations. The fleet today, Intelsat, stands at 24 satellites, and 801 is going to go into its Indian Ocean service region, which is after the Atlantic Ocean region, where the company has the most satellites.
La trajectoire est nominale.
With 801, it'll be 6. There will be 6 Intelsat 8s, and Ariane is going to launch the first 4 of those. The next one will be sometime this summer with 802. The company moving toward a more, I guess you can say, commercially oriented service than its traditional public service markets.
Well, Joshua, as you can see, altitude is dropped to 190 kilometer
Altitude drop,
range,
the
and then
speed is up.
speed is up by 8.4 kilometer per second. And we're coming closer and closer to the end of the
Propulsion
power
nominale,
flight.
pilotage calme.
Ariane and Intelsat go back a long way. Since 1980, of the 30 Intelsats that have been launched, 13 have been launched by Ariane. Tonight's the 14th. That's over 40% for Ariane.
Il reste environ 2 minutes de propulsion.
2 minutes propulsion left in the third stage. This represents, the figure is 86,000 kilos injected into orbit. And for Ariane has injected almost 42,000 kilos of those. That's almost 50%. Interesting to compare the 8s and the 7s. A little bigger, a little more powerful. 4.2 meters, Intelsat 7, 5.2 meters for the Intelsat 8s. Lifespan's about the same. Capacity, Intelsat 7s had 18,000 circuits, phone
Tous les
circuits.
paramètres sont normaux.
The new ones will have 22.5. 3 TV channels, that's the same. If you go way back to Early Bird, this is even more interesting. First Intelsat, 1965. And
Il reste 60 secondes de propulsion.
compare it with the 8s. Early Bird was 2 feet tall, and this one is 13 feet tall. Early Bird had a lifespan of a year and a half and had 240 phone circuits compared with 22,000 on the new one. So that's a lot of evolution in those 30 years for the
Trajectoire
Intelsat
stable,
folks.
paramètres nominaux.
Didier just reports that all the parameters are nominal, and less than half a minute of the power flight of the third stage.
And we're doing fine.
Il reste 30 secondes de propulsion.
30 seconds left. Terry Edwards was telling us earlier in the week that the campaign went very well. There was a lot of free...
Acquisition par la station de Libreville.
And we've just been picked up by the African station now. The testing, he said, was finished earlier than planned because it was conservatively planned, since 801's the first of a series. There was no time pressure. He says everything went very smoothly. Edwards was coming here for 15 years. He's
Tous les
launched all
paramètres sont
the
normaux.
Intelsats on Ariane.
Extinction H10.
There we have the third stage burnout.
Power
After that
flight
long
is
burn.
completed. Now the
Mise en orientation du composite.
Now what's happening? We have a sequence of spin ups.
well, we at Ariane Space we call this phase at this
Orientation nominale.
space ballet by the
Space
payload
ballet.
composite, because payload composite is doing all these maneuvers in space to orient the composite to the good position in order to separate the Intelsat 801 spacecraft.
Fin, poursuite, ascension.
All right. Ascension Island is no longer tracking us. We're being tracked by Libreville in Gabon only. Remember our mass profile? We started at 357 tons. After third stage burnout, we're down
Fin
to
de la manœuvre d'orientation du composite.
5.5 tons. And Intelsat 801 weighs 3.4 tons.
Payload orientation, payload composite orientation is completed, getting ready for the Intelsat 801 spacecraft separation from the launcher.
Stabilisation du composite.
How long does this sequence take now, this space ballet you were talking about?
Up to 2 minutes.
2?
Début, mise en spin du composite.
This is the spin up, what they
The
call it?
composite is spinning, this separation with a spin.
Séparation Intelsat.
Well, there we are. There's the good news. Okay, so mission accomplished. You heard the applause. Smiles at the Intelsat bench. 801 now on its own. Now that 801 is up, this is what's going to happen in the next few weeks. The first acquisition will be in Perth at about 39 minutes after liftoff. That's
Which
shortly.
means like within 20 minutes, the first acquisition should take place.
There will be 4 apogee firings, the first one a test, between the 1st and the 6th of March. Solar arrays deployed on the 8th of March. Then the testing begins. The bus testing begins on the 10th for 2 weeks. The in-orbit payload testing begins on the 24th of March, stretching over to the 2nd of May, and drifting to its orbital position at 62 degrees east between the 3rd and 11th of May, ready for service on the 13th of May. Francis Avanzi is going to come in and make a speech shortly, and we'll carry that for you. Handshakes and smiles all around. We mentioned the close relationship between Intelsat and Ariane. The Ariane launchers actually anticipated, I guess you could say, Intelsat's evolution of the satellites. An example, the S1 building here, which was refigured for Intelsat 5, which couldn't get through the door. Right? It's bigger. The fairing of the launcher was enhanced for Intelsat 6, and of course Ariane 5 is being adapted for the new Intelsat 9 series.
And other payloads, of course, coming as big as or larger size.
So tonight's launch, Ariane has launched 94 satellites, 65 Ariane 4s, and remember, 744Ps, very important.
This was the 7th.
125 satellites. With tonight's launch, we are on target for our goals of this year, which are 12 launches scheduled and 18 satellites. And we have now launched 23 times in 23 months, which is not bad.
Correct.
We're going to be hearing from, I believe, Francis Avanzi and
Mr. Claude
Bourgeot from Intelsat. I think we'll be hearing from Mr. Avanzi first, who should be speaking in English, making his way out of the fishbowl where the technicians are, out into the VIP area. As soon as he has a mic in his hand, we will go to him, and we'll have a French translation for anyone who cares to take that.
Alain, tu es prêt?
À tous de DDO, fin de mission lanceur. Fin de chronologie V094. Les moyens sont remis à la disposition des adjoints. Le débriefage du lancement en salle Max Hauser demain matin à 9h. Merci à tous.
We should have another launch replay in just a few moments, taken from another camera from another angle. And I think we're ready for our speeches now. We'll hear first from Ariane Space COO, Francis Avanzi.
Okay, ladies and gentlemen, finally we got it. As you saw it live, our Ariane 4 achieved its mission for V094. The spacecraft, now Intelsat 801, is in its GTO orbit, ready for the next step for the final orbital position, which will be at 64 degrees east, which means over the Indian Ocean. The flight has been, as you saw it, smooth and accurate, and our Ariane 4 once again delivered. It delivered after having been delayed by 1 day due to some weather conditions in altitude on yesterday, and due to with another delay today for some ground conditions. But we finally got it at the end of the window. This flight tonight is our second flight for 97, the third spacecraft placed into orbit, and this also has been the 23rd flight of Arianespace out of the past 23 months, confirming the Ariane capacity and regularity. Now, obviously, my thoughts goes to our customer, Intelsat, who has been a promoter of technical and conceptual innovation in space telecommunication for a long time. And it's really fair to mention tonight here that Intelsat has been the first Ariane export customer with the first contract in 1980 and a first launch in 1983 with V7. And since then, a very constructive and very long-lasting cooperation has been established between Intelsat teams and Arianespace team, with mutual recognition, solidarity, and support through a transparent and fully integrated relationship. And I would like to mention here that Terry Edwards and his team has been really a key point and a key factor to this relationship really from day one. And thanks to this cooperation and also to the anticipated adaptation of Ariane vehicles to the needs of Intelsat, Arianespace has been granted by Intelsat since 1980 of 17 satellites to be launched, representing 55 tons into orbit and also representing 52% of all the spacecraft of Intelsat that are now launched by Arianespace. And tonight, this has been the first of the new 800 series. And I want to tell you that it's been a great honor and a great pleasure to serve you again, and that we are very proud to have made this challenge tonight, and on behalf of Arianespace team and all the members of Ariane community acting in Europe, in Washington, in Tokyo, in Singapore, and here in Kourou, I want to thank you for your confidence, to thank you for your way of dealing as a team with all of us, and also to thank you for giving us the opportunity of improving our service through new innovative challenges. All the best success in your operations. I also want to take this opportunity to thank our friends from Lockheed Martin Telecommunications, along with Intelsat and our team for the outstanding teamwork with Arianespace and the CSG during the preparation of this campaign, and also during the preparation of all the other campaigns that we are doing all together. I would like now to ask Claude Burgio, who is the Vice President for Engineering of Intelsat, to join me for his remarks. Claude, it's been a pleasure.
Thank you very much, Francis. Bien joué, bien joué. Excellente mission. I think, Francis, before I start my speech, I have to say my team thought that we were planning for the last 2 days this race of drama by postponing launches by 1 day and postponing it again. And, well, let me say it was not a game. It was a very serious business, and we are very happy of the result. Well, today, February 28th, Ariane Espace has successfully launched from French Guiana this Intelsat 801 aboard, as you saw, the Ariane 44P. The 801, which has been manufactured by Lockheed Martin Telecommunications, will be deployed in the Indian Ocean region at the 64° east orbital position. It will bring to 5 the total number of high-power satellites deployed by Intelsat in that region. The 801 will provide voice, data, and video capacity to meet the growing needs of Intelsat in that part of the world. Its coverage extends from Europe and Africa in the west, and the Indian subcontinent, and to Asia and Australia in the east. 801 has 46 transponders, providing a mix of C-band and Ku-band capacity, including 2 steerable Ku-band spot beams. They represent a total of 76 units of 36 megahertz. On behalf of the Intelsat organization and its Director General, Irving Goldstein, I would like to say that we are very pleased with this successful launch of Intelsat 801. And I would like to congratulate Arianespace for this success. We liked it. I would like as well to congratulate the Lockheed Martin Telecommunications team and the Intelsat team for their exemplary performance. But you know, our work continues as we have to bring this satellite in its final position and to perform in the next few weeks acceptance testing. The satellite is scheduled to begin service in May 1997. So, well done again, Arianespace. Bravo à toutes vos équipes. Nous reviendrons.
Thank you, Claude. Thank you, Claude. I'm sure that you will come back. Many thanks to all of you, and I'm sure also that you will come back to support us for some new flights. Long life to Intelsat 801, and the next rendezvous will be with V095, which will be on the 11th of April, with Taicom 3 and BSAT 1A on board as passengers of Ariane 4. Thank you again.
Right, so Francis Avanzi, Arianespace number 2, mentioning again the relationship between, the very close relationship between his company Arianespace and Intelsat. The first contract, the first launch going back to the early 80s. We've got our second launch replay coming up now from a different camera. And some nice shots. The second replay you saw of tonight's successful Arianespace mission, flight number 94, launching the first of the Intelsat 8s. Francis Avanzi again thanking Intelsat for its friendship and cooperation and expressing his pride at the Arianespace contribution. Claude Bergio, VP Engineering for Intelsat, congratulating the teams and saying, we'll be back. And we will be back with the next flight, which is, as Francis Avanzi said, in April, Mesut?
Yes, 11th April, the next one.
Which is a double launch.
We'll be launching Taicom 3 and BSAT 1A spacecraft.
Right, so, amid all the cigars and the champagne, and the handshakes all around, and the very happy faces of the people, because after all, all's well that ends well, and what's life without a little drama, right? Arianespace, the master dramatist, providing everything right down to the suspense. So, on behalf of everybody here at the Space Center, and for my friend Mesut Chichiker,
goodbye.
This is Joshua Jampel. Thanks for being with us, and we look forward to being with you next time. Good day, everybody.